16th is from wave, Doppler's effect, and finally a small part of beat. Now it says there are two sources of sound, S1, S2. They produce the same frequency, 660 Hertz. So it's something like, let me make this as the line, and along this there is S1, there is S2, and both of them produce 660 Hertz. A listener is moving from S1 towards S2 with a constant speed. So the listener or detector, whatever you say, let's say the speed of the detector is Vd. And let me even write here, the frequency that's given is 660 Hertz. Both produce the same thing. And in the course of its journey, the detector detects beat of 10 beats per second frequency. And beat happens whenever there is two frequencies simultaneously being played and slightly different frequency. So it all occurs because, you see, when the detector goes in this direction, the sound produced by 2, the apparent frequency heard would be higher, and for the frequency produced by 1, the apparent frequency registered by the detector would be lesser. So there are two frequencies, and if the velocity is not significantly, towards the speed of sound, or you say that the speed of the person or the detector is small, then in that case the difference in frequency would be coming into the range of beat. The whole idea is that. And we need to calculate the speed of the detector. Speed of sound has been given as 330 meter per second, and the beat is 10 beats per second. That's the beat frequency. Let's say the first frequency registered by detector and the frequency produced by S2, let's say that's 660 is the real frequency into speed of sound 330 plus of Vd divided by 330. That's the first thing, okay? And second, let's try to calculate the frequency registered by detector and the frequency produced by S1. That's 660 multiplied by 330 minus of Vd upon 330. So one is this frequency, other is this frequency. The subtraction of this frequency is called as the beat frequency, and that has to be equated to 10 as per the given question. Rest is a straightforward one. You can easily calculate the value of speed. You do that, you would get 2.5 meter per second. So option number 3 is the correct one. Let's move to the next. Okay, the 17th one. This is from RL circuit. Now here, this is an RL current buildup circuit, and we need to calculate the total charge that passes through the battery from this time to this time, and this time you see it's also the one-time constant. Now during the process of current buildup, the current passes through this. Passage of current means, of course, the charge is passing through that. And we need to calculate what is the total amount of charge that has passed in that given time. And that is going to be straightforward. You see, if I calculate I as a function of time, that is E by R 1 minus e raised to the power minus RT by L. That's a standard equation. And I require to calculate the total charge passed. So the total charge, if I denote it by Q, is going to be integral I dt, and the limit would be from 0 to L by R. This is how it goes. All you need to do is that you need to calculate, and yes, e raised to the power 1, the value is a standard one, 2.7. So with that information, when you solve for the total charge that has passed, option number 2 is going to be the correct option for this question. Let's move to the next. Question number 18, the gravitation. And it says, ratio of weights of a body on the Earth's surface to that on the surface of a planet is 9 by 4. That means if I go for this, acceleration due to gravity at Earth and acceleration due to gravity at planet, this ratio has to be 9:4. So this is the given point. See, it says that the weight is in the ratio of 9:4, the ratio of weight at Earth to that of planet, so that will be acceleration due to gravity ratio. And it says the mass of the planet is 1/9 of that of the Earth. That means it is less massive than Earth. But yes, if you see the ratio, that's going to be me upon re square, and this time is mp rp square. That's a straightforward. Small g is capital G, capital M by r square, symbols having the usual meaning. Rest, all is there, see? The mass of planet is 1/8 the mass of Earth. You need to calculate the ratio of the planet. I think things can't be easier than this. Option number 4 would be the correct option. The radius of planet would be radius of Earth divided by 2.